All right, here we go. So this is on worksheet 4.1. This is number 4.
Oh, it's 0.2.
And I'm going to actually grab a proper pen instead of this stupid thing I'm using. All right, so here we go. We got a 5 kilogram box. So mass equals 5 kilograms. Right away, you should put in your force of gravity. So 5 times 9.8 is going to give you 49 newtons, negative because it's down. All right, the box is pushed across the table using a force of 30 degree, using a force that makes a 30-degree angle with the horizontal. So here's maybe why you got tangled up on this. It's being pushed at an angle that makes a 30-degree angle with the horizontal. And I should have been more explicit on this, but I mean, if I push that desk, am I pushing up or down? Down, right? So when I solved that, I assumed that the force was down. Now, I guess it could be possible that maybe the box is very tall, and your person is like pushing up, at some sort of weird angle. Well, he needs to go to a doctor, his leg's all messed up. So I guess you could be pushing up. I just don't know why you would do that, right? So my intent behind the problem was that you were pushing down. If you didn't interpret it that way, that's my bad. I'll make sure I word the problem more carefully. Was that what was messing you up?
Maybe.
Maybe. Okay, so I'll keep going. Margaret, and then Sebo, did you have a question?
I was just wondering what the answer is if you did have him pushing it off.
I don't know. I didn't figure it out. I'm sorry. It didn't occur to me until this minute that might be an issue, to be honest. Sebo, what do you got?
So could you just drop a triangle?
Yeah, I was headed there. Yeah. Okay, so when I solved this problem, I assumed that the force of Roy was like this. And then it tells you... Oh, it doesn't tell you the force, duh. Okay, so there's your force. So there's going to be an x component to that force and a y component to that force. It does tell you that this angle is 30 degrees. What's wrong?
Nothing.
Okay. All right, let's see, what else do we know? We know that the box accelerates at 3 meters per second squared. And that the force of friction is 10 newtons. So which way is my friction going to act in this problem, you guys? To the left, right? In the opposite direction that it's moving and being pushed, right? Which happen to be the same in this problem. All right. What kind of friction here, you guys? Static or kinetic?
Are we moving?
Kinetic.
Yeah, we're moving because it's accelerating, right? So it's got to be moving, so it's got to be kinetic. So that's negative 10 newtons. So I think that's everything that it gives us. So we got to make a free body diagram. We got to find our coefficient of friction. We got to find the force F. So thoughts about where to start? Why did I give you the acceleration? So you can find the net force, right? Okay, well, cool. My net force is mass times acceleration. So 5 kilograms times 3.0 meters a second squared to get 15 newtons. So point for me, you guys. Which direction is the box accelerating in? This way. And therefore, which direction is the net force? Same way. Remember, your net force and your acceleration always act in the same direction because the net force causes the acceleration. So, what do I call the force that's, I guess there are two forces that affect the acceleration, but how do I want to ask this question without just telling you the answer? So, are there any other horizontal forces besides kinetic friction? The force of Roy in the x direction, right? Now, regardless of which way you had your force, Margaret, you asked before how it would be different if your force was up. The answer is the same, actually. Your coefficient of friction will be different, but your force of Roy will be the same. All right, so anyway, I'm getting ahead of myself. It's like 28.9, I think. All right, I'm almost there, so hang tight for 1 second. All right, so we know our net force is 15 newtons, right? So can't I find the force of Roy in the x direction? Right, we're just saying some unknown force minus 10 equals 15. So what does it have to be, guys? 25 newtons, right?
Okay, then it's right.
And then you do a little bit of trig to find FRX and FRY.
The coefficient, if you do it the other way, is 0.25.
0.25.
We got the same thing.
Do I agree with that? Yes, right, I do agree with that. Yeah, that makes sense. I was thinking it would be lower, but it should be higher. Okay, yeah. Yeah. Okay, so is everybody good with what I did here? And does everybody understand now that I have the adjacent side and the angle, I can use cosine and tangent to find the hypotenuse and the other side, right? All right, so if you do that, the force of Roy, like I said, turns out to be 28.9 newtons. And the y component turns out to be, what, like 14.45 or something like that? Somewhere in that neighborhood. It is negative, yeah. Cool. Any problems with how I got those numbers? All right, so that was part of the problem. The next thing we need to do is find our coefficient of friction. So let's finish our drawing. So there are two forces that I've yet to put on the drawing. Which ones? Normal force and the y component. So we got to do that y component first. Please remember, normal force is always the last of your vertical forces. So now I can figure out what it needs to be, right? And net force vertically should be 0, right? Because the box isn't going to move up or down at all, right? So this force needs to be, the normal force up here needs to be big enough to cancel out gravity and the y component. And so you get, what, 63.45 for your normal force? And now you can find your coefficient. Force of kinetic friction is coefficient of kinetic friction times normal force. Or coefficient is force of friction over normal force. So we get 10 newtons over 63.45, and it gives you 0.19. Cool. Put it on the floor. Do you guys have any questions about how I solved that? Oh, actually, I'm just being silly. Thank you, I appreciate it. Okay, are we good? Okay. Finally, number 5 was literally just vector addition.